Hello everybody, and today I'm going to share with you how we have integrated VI grade simulators into our product development cycles, especially in the area of automotive sound design. So today I'm going to cover some context on our technology, the simulators we're using, and some of our observations and next steps. So I work in Harman's automotive division, so our motto is Consumer Experiences Automotive Grade. So we're trying to deliver in-cabin experiences that focus on the passengers and customers and how they interact with our products. We develop a wide array of products from advanced displays, infotainment systems, and audio systems. You might be familiar with some of our brands like AKG, JBL. Those are our audio systems that we deliver in the automotive space. And we believe in excellence through partnerships. So we have partnerships with our parent company Samsung in the display field. We also partner with our customers to deliver award-winning audio systems in their cars. We partner also with technology partners like VI grade in areas like simulation. So the area of Harman technology that I work on is called Halosonic technology. It's our brand name or our trademark name for our active noise cancellation and active sound synthesis space. So our active noise cancellation, we're working on products like road noise cancellation and engine order cancellation to quiet road noise or vehicle noise to make the cabins quieter for passengers so they can enjoy our other audio features or entertainment features, or so that they can have conversations without raising their voices to each other. We also have other solutions called sound synthesis. So those are in the area of internal sound synthesis and external sound synthesis, which you may know as AVAS systems for pedestrian alert applications for electric vehicles. These systems, sound synthesis started out as a way to enhance the sound of more fuel-efficient powertrains, and it has continued on in the electric vehicle market where we're adding sound character to sounds that or to vehicles that don't have much sound character. So these features live in our infotainment systems or other audio systems, and they add their sound to the production audio system, and they're tuned in production applications. So just diving into today, we're talking more about electronic sound synthesis. So the way these systems work is they bring in vehicle guiding signals over the CAN network, so like power, RPM, load, speed, various other signals. They bring those into our synthesizer. We're basically building a synthesizer on wheels, and then they combine their output signals with the entertainment audio, and that's played over the speakers in the vehicle. So we have a wide range of what we call instruments and audio effects that are used to create these sounds. So every year in the pro audio market, new products like guitar pedals, audio effects, synthesizers are released, and these products often influence trends in popular music. So like a great example I think everyone remembers is T-Pain popularizing the auto-tune effect. So he was able to differentiate himself from other artists using those effects. So we also have a huge backlog of ideas that we want to use to help our customers differentiate themselves from other car makers. So we do this using an agile development process. So this is the very, very right side of the V model where we're coming up with concepts and ideas. So we use agile development processes. It's similar to, if you've heard of Alex Cohen, his hypothesis-driven development or the scaled agile framework. So we organize our backlog. So these methods actually work well for projects that involve like testing, research, a high degree of uncertainty. So on the left we have our product backlog. So maybe different synthesizer effects, sound designs that we want to demonstrate, features we want to demo. We organize that into product increments, so quarterly product increments throughout the year. And then we divide that work into sprints, which are more of a 2-week cycle, where at every cycle the team comes back, shares their progress towards the goal, and we can update, make revisions to our plan. And then at the end of the quarter, we come back to a wider audience and share our results. And once we're satisfied with that feature working and sounding to our expectations, we begin the production software processes like unit testing, software compliance, and processor optimization so that we can get it into production. So this process is one of the challenges we face is how do we demonstrate these features in a way that enables meaningful feedback, especially in the context of the vehicle. So the solution that we worked on with VI-Grade is integrating our sound design library into the VI-Grade NVH simulator. So the NVH simulator is doing all of the vehicle simulation, and Harman has integrated our sound library as a sound object in the sound simulator. So the simulator is sending the control data over to our library, and we send the audio samples back, so it's added in just like another layer or another sound component. So we find that the desktop simulator enables our team to manage multiple configurations, so they can switch between different versions, different software releases by using different sound objects. We can share these sounds across team members. We have team members around the globe working on sound design and feature development. And then we can test over a wide array of use cases like fixed driving modes, or we can use playback from recorded vehicle in the fixed driving mode, we can use playback from a recorded vehicle, and the free driving mode, we can interact with the vehicle like a driver in the loop. Let's see. And we can live tune our algorithms while we're running in the simulator, so we can connect our tuning tool directly to our algorithm while it's running and change parameters and hear the difference live in real time. So then when we get to our wider coverage, our PI demonstrations, where we're bringing more stakeholders. So at our Novi office, which is about 10 minutes from here, we have a static simulator on our first floor, and this enables us to set up a demonstration, and we can bring in a wider audience of stakeholders. They can sit in the vehicle, interact with the visuals. So we have the visuals set up from WorldSim. Car real time is creating the driving model, and then NVHSim is hosting our library just like it was in the desktop application. And we can also, if we want to interact with the audio library, we can sit in the car and we can connect over Ethernet directly to the algorithm running on the NVH simulator PC in the simulator. And here's a couple examples. So on the left is an example of a synthesis technique that uses granular synthesis, and it's a demo of that creating a combustion engine sound. I think it should play. So that's one demo, and that gives us the option for playing that in a sprint review. We can have feedback, people can comment on it, and we can take that feedback and work on it in the future. And then in another demonstration, so this is actually some sounds. There's 3 sounds in this, and they're being demonstrated as part of a larger scale demonstration actually this afternoon. But I'll show you at least 3 sounds from that demo. So a couple examples. So are we ready to give up our test vehicles? Not quite yet. There's still some differences we see between our simulator technology or our simulator setup and our vehicle testing. And I think that's just a matter of time. We've had access to our static simulator for, I think, a handful of months now. So these are things that we're interested in looking into more. So the first one is translating a tuning that's done in the simulator to an actual vehicle is highly dependent on the powertrain model. So higher fidelity models, if they're available, that will reduce the amount of time that people spend tuning these algorithms in the car. Similar to the previous presentation, where sometimes the data in the simulator is just a little bit too idealistic, and yeah, we can accommodate that in the future. Also, driving scenarios. So we recommend testing across a wide range of driving scenarios, and this helps catch corner cases early. For example, parking lot maneuvers, uphill, downhill. If we can do all of these in a virtual environment, it saves time of driving to the right roads, getting access to a test track. I mean, even the test tracks that are rentable are completely flat, or customer test tracks as well. And then, also, I think I previously mentioned this data modeling. So yeah, some of the signals from the simulator are idealistic, and we can improve the time we spend actually doing tuning in the car, and we can shift left some of the debugging if we have simulations that are more accurate. One of the ways we found is that we can use the fixed driving models to go take a vehicle log and bring that back to NVH simulator and play that back if we want to deep dive into some type of an issue. We also see some differences in the target system. So when we're running in just purely in the NVH simulator, we're not using something that represents our production hardware, or it is production representative hardware or software, but when we add more features and integrate it into the car, things can change. There can be differences in the vehicle, and you can bring in your hardware to the simulator environment, so create more of a hardware in the loop test. Another thing is that there's differences in audio systems. So we sell many brands and many audio configurations. But we have one simulator, one fixed setup. So we're thinking of ideas of how we could maybe virtualize different audio cabin configurations in order to be able to have someone tell the difference between a JBL system or a Harman Kardon system, along with the sound features that we're adding. So we foresee upgrading our audio system in our static simulator. The audio latency. So audio latency scales with the buffer size settings for the sound card drivers, and it seems like it's within the 5 to 10 millisecond range, and the whole system together seems that it's within the human tolerances for interactive driving. We're also work on active noise control applications, so which requires lower latency latency c. So we think that is probably something that would be better suited towards a hardware in the loop type application in the future. And then user behavior. So we've seen users behave differently in the static simulator compared to an actual vehicle, just because the feedback isn't there. Maybe some of the other simulator products would be better suited for that. So the user may drive a little bit more aggressively in the simulator. But on the same token, sometimes if we want to demo a feature in the car and we want to drive at low speeds around public roads, we may change tuning parameters to make it easier to induce a condition in the car. So there's also some things we simulate while we're actually in the vehicle as well. Just to summarize, some of our key benefits. So we see the use of the simulators at Harman to foster collaboration between our software and sound design teams, and able to demonstrate that to stakeholders in a safe environment. And we can iterate in a rapid way in the simulator with a greater variety of test conditions than is possible with the vehicles today. And if you're interested in active sound design, I'd be happy to talk to you about that today, or you can reach out to me at my contact information here on the page. And I think that's it. Thank you very much.